have time to be fun. Okay. Today's focus is a revisit of classifying matter and a lot of the vocab that comes with. You'll find on the AP that multiple choice questions tend to focus on some of these simpler ideas, so I need to make sure that you've got this basic vocab. Again, hopefully this is absolutely boring as we continue to revisit. If you're watching this at home, make sure you've already got the slides in front of you. Make sure you've got the slides in front of you so you're not at a disadvantage, because this is not incredibly easy to see. And it's crooked now that he hit it with his elbow on the way out. Okay, so one of the things I want to address right away is that a lot of times in pre-AP, the idea that is portrayed is that mixtures can be separated and pure substances cannot. And I understand the idea behind saying it like that, but make yourself a note. Mixtures can be physically separated. All right? You don't have to do a reaction to separate a mixture. All right? Whether it's homogeneous or heterogeneous, you can separate it through physical means. Compounds can be separated, but they require a chemical reaction. You can only separate compounds chemically. And that's an idea that I worry that if someone asked you that point blank, that you would miss it. All right, if you ran into a true-false question that said, only mixtures can be separated. You're like, well, yeah, that sounds right. But that's not, compounds can be separated, but chemically. So a few things to go over in regards to classification of matter, and we'll start real simple with the states. I just want to make sure when you're looking at solid, liquid, gas, and we'll go into them in more detail in their own time throughout the year, but I want to make sure you've got this down. If I'm going from a liquid to a gas, am I adding or removing energy? Adding. If I'm going from a liquid to a gas, am I adding or removing energy? Adding. All right? So keep in mind that going from solid towards gas requires an input of energy. All right? Usually in the form of heat. The easiest way to not let a simple question like that trip you up is just always go to water as the example in the three states. Because you know how to make an ice cube become vapor, right? You got to boil it. So that's the input of energy. So don't let that be confusing in any way. Physical versus chemical changes is mentioned on the slide. Remember, a physical change is one that creates nothing new that you can identify after the change. Whereas the chemical change, you can find something that is not there. Say it right. You can find something that is there that was not there prior to the change. So, pure substances versus impure substances is the largest separation of matter classification. If you remember, my pure substances are going to be my elements and compounds. Elements are the guys that have their own square on the periodic table, whereas compounds are going to be a combination of squares in order to still create a pure substance. Both of them considered pure because they can't be simplified in any way. My impure substances are the mixtures. Make sure homogeneous and heterogeneous are two words that you are equipped with. The homogeneous mixtures are going to be the solutions. Hey, there's a fun word. Who can tell me what two things you have to have in order to have a solution? Solvent and a solute. All right? A solute with a solvent makes a solution. And remember, solutions are by definition homogeneous. The idea being is that the items that are mixed together are uniformly put into the solution. And one of the things that we say, since it's homogeneous, is it tends to look the same throughout the mixture. You can't see the parts that have made it up. Was that a question, Diego?
So solutions fall under homogeneous?
Exactly, yes. Solutions are a type of homogeneous mixture. Heterogeneous is the one where when you mix the components together, they can generally still be seen. Some of the examples that we use for intro are things like Chex Mix and fruit salad, where it's obviously a mixture that could be separated by physical means. You can put the parts into their own little groups, and by just glancing at the mixture itself, you can readily identify the parts that were mixed together. So, real basic review over some of the vocab that you definitely want to know for classification. Yes?
What about salt water and sugar water? It's always for those concepts.
What about salt water and sugar water? Both of them are homogeneous. All right. The idea being, because whether it's salt water, if you go to the ocean, right, and you take a scoop of water and I take a scoop of water from a different wave, they should have the same salt content in general for equal distribution. All right. Same thing with Kool-Aid, which is sugar instead of salt.
Oh, that's sugar water?
All right. Kool-Aid?
Yeah.
Wait, have you not made Kool-Aid?
No, I haven't. I didn't know that was sugar water.
Well, I mean, it's sugar that you add with a powder, so that's one of the general components. I mean, but yes, they're like, oh yeah, it's all sugar. So here's the pictures that I hope you've already drawn in your spiral, because I don't want you to draw them while I'm talking. So please get better at this if you're not already good at it. These are called particulate diagrams. What I need you to be able to do is to apply the idea of solid, liquid, gas, apply the idea of mixture, compound, element, and even as far as homogeneous, heterogeneous, based on the way these pictures are drawn. So it's real simple. Quit drawing and look here for a minute. If the picture has only one type of shape, total, all right, maybe it's a bunch of the type, but only one general type, then that's trying to convey an element to you because there's only one type of thing there. The compound would also be generally one type of thing, but you'll notice that it's different shapes that are married to each other, trying to represent a bond. The mixtures are going to be when the square contains different types of items that you could take the items and put them into groups, because of course mixtures can be separated physically. So the moment that you see a triangle here and a square over here, all right, well, it must be a mixture because you could make a square pile and a triangle pile. Now, it goes a bit further though, because the states of matter can also be shown. The solids tend to stay along the bottom in the most organized fashion possible. Liquids also tend to stay along the bottom, but in a slightly disorganized way. They'll do something to show you that this could have more order to it. All right? It's trying to represent the liquids as having the ability to flow, of course. And then the gases are going to be the ones that are not along the bottom, free floating. One other distinction that they'll make are between homogeneous and heterogeneous. If it's showing you a mixture and it wants you to figure out whether it's uniform or not, if you could draw a line, maybe a very slightly curved line, but generally a line through the square, and separate the square into those groups that you would normally by trying to separate, then it's heterogeneous. It's trying to show you that just by looking at the mixture that you can see the parts to the point where you could easily separate them. If they're mixed in a way that you couldn't draw a line or a slightly curved line to separate them into two groups, it would be homogeneous because it's so uniform that you couldn't identify the parts, the place to put that line. That was a lot of talking. Let's practice. Look at A. Does it appear to be element, compound, or mixture? Element's correct. There's only one type of thing in there. Solid, liquid, or gas?
Gas.
I would say gas. They're floating around. Now, if you haven't drawn the pictures yet, they're never coming off Schoology. All right, you can go and catch up on this. You can just maybe write down the answers now, so you're not drawing a bunch of pictures quickly, and just add the pictures tonight. What about B? Element, compound, mixture. Mixture. All right. Now, someone said compound because they saw water here. And it might not be water, but that's what water generally looks like. But yeah, water is a compound. But look, it's mixed with this other triple bonded item. It's definitely a mixture because we could put them into two groups. What type of mixture? Homogeneous or heterogeneous? Heterogeneous, because I could draw a line right through there and it easily be separated into two groups. C, element compound mixture.
Element.
It's a mixture, all right? You'll notice different shapes, all right? In this case, the shape's technically the same, but different sized shapes. All right, everything on this slide uses circles. So they didn't get real creative. But heterogeneous or homogeneous?
Homogeneous.
This one would be homogeneous. There is no way I can draw a line through there to easily separate them, which means the author of the particulate diagram is trying to show that it's a solution. All right, what about D, element compound mixture?
Compound.
Compound is correct. Solid, liquid, gas.
It's a liquid.
Solid.
Liquid.
I don't know.
It's not like all in a row.
I would say it's liquid.
Oh, yeah, because those are like up.
It's straight across showing you that it's solid or liquid, but do you see how they have purposely given it a little bit of disorder? All right? They've messed with some of them, and if you can't